Okay, so this is going to be a quick lesson of square roots and cube roots. Um, I guess it's sort of a review, it's sort of new stuff. I'm sure most of you probably know what square roots and cube roots are. But we're going to go over them and how they're related to perfect squares and perfect cubes. Okay, so first off, we'll go over some terminology. Perfect squares, let's just read this definition together. A number is a perfect square if it has two equal factors. One of these factors is the square root. Completes and become familiar with each of the perfect squares in the table below. Okay, so at the top here, you can see that these are all basically the square roots, and these at the bottom of the top portion, and the bottom portion are all going to be the perfect squares. Okay, so the first two are already done from you. Uh, Second one's 2 squared is 4, so 4 would be the perfect square in this case, because the factor multiplied by itself will give you 4. So, and then we'll just fill this out really quickly. So 3 squared equals the perfect square 9. 4 squared is 16. 5 squared 25. 36. 49. 64. 81. 100. 121. 144. Okay. So yeah, if you go backwards, if you square root it, the square root sign, which is obviously just like that, and you'll get the square root. So pretty simple. Okay. Next part. So square roots, if the prime factorization of a number generates a pair of prime factors, the number is a perfect square. Okay. The product of one of each number in the pair of factors is the square roots. Okay. So this is when you're gonna have to do a factor tree. Okay, so if you simply didn't have a calculator, like if you wanted to figure out what's the square root of 324, how would you do that? Obviously, if you had a calculator, you could just type in the square root sign with 324 and it'll get the answer. But what if you didn't have a calculator? How would you do this? Um, so, so we're gonna do some prime factorization, or sometimes call it factor tree. So prime factorization is we're just gonna break down 324 um, all the way down into its prime numbers. So what two numbers multiply to 324? And you can choose any two numbers that multiply it. There's a bunch of different ways you can do it. I'm just going to choose 2 and 162. And then you're just going to keep breaking these down into other numbers that multiply into them. So you can break it down into prime numbers, not including 1. Like I could go 1 times 2, 1 times 2. That's going to be forever. But so 2 is broken down already. So 162, we'll break it down again with 2 times 81. Okay. And then from here, we can break it down. So 2 is already done again. So 81 multiplied by 9. So 9 times 9 is 81. And then we can break down the 9s to 3 times 3 is 9. Okay, so now we got our prime factors, right? So we got our 2, 2, 3, 3, 3, 3. Okay, so I'm just going to write it down because the next part is the product of each one of the numbers in the pair of factors is the square roots. So we basically it's the same. We got to pair them up. Okay, so we got to let's take the 2's down. So we got 2 2's. So we got a pair here. We're trying to find pairs. We got 3 3. So 3 and 3. We also have, let's put an x here. So 3 times 3, just so you know it's not 33. And we have another 3. So 3 times 3. Okay. So what do we have here? So from these two, this pair, we have 1 2. We're just taking 1 2 from it. We have another 3 here. And we have a 3 here. This is really messy, but I'll do the next one a little bit cleaner. So we have a 3 from that pair, a 3 from that pair, a 2 from that pair. So basically you're pairing them up and you just take one of them out. Okay, so once we have that, you're going to take what's left over. So 2 times 3 times 3, and I'll write over here because it's right on space there. 2 times 3 times 3. So what's 2 times 3 times 3? You get 18. So 18 is the square root of 324. Okay, so that was messy. I'll try to do this one a little bit cleaner. But just to review, you break it down into its prime roots using prime factorization, which is just this little tree method. So 2 times 162, you broke it all the way down. And finally, you got a 2 and a 2. So you don't really need to write it here. So there's one pair, so you got 1, 2. You got 3 and 3, so you got another pair, so take one of the 3's out. Another pair here, 3 and 3, so take that 3 out. Then you just multiply all those 3 out. So 2 times 3 times 3 gives you that 18. Okay, so let's do another one. I'll do this one a little bit cleaner, and it's the same sort of idea. We just got a real big number. So our goal here is, how are we going to find the square root of 1,296 using prime factorization? And pretend we don't have a calculator. So let's do this one. So I'll write a little bit smaller because I don't want to run out of room again. So two numbers and multiply 1,000 to 1,296. So you can just play around with it. So eventually you might get 6 times 216. Okay. Okay, so we can break down the 6 pretty easily. You could also, like, if you couldn't think of this, like, oh, 6 times 216 is 1,296, you could also just done, like, divided by 2 kind of thing. So 2 times what equals 1,296, and done it that way. Okay. So 6 we can break down to 2 times 3. Yeah, let's break this down as well. So this one, for example, say I didn't know big numbers that multiply into 216. Let's take the easy root, the even root. Remember our rules for even, and how do you know if number 2 or 3 or 4 or 5 or 6 or 7 goes into a large number? So you can review that in the previous lesson, I believe it was 3.0. Okay, so 2 times 108. Then we can't break down 2 anymore because it's already a prime factor. So 108, break it to 2 times 84. And then we got 2 times 27. And so we can break down the 27 to 3 times 9. And finally, 3 times 3. So there we go. We broke it down. We have the prime factors. So 3, 3, 3, 2, 2, 2, 3, 2. So next step is we're going to pair them up. Okay. So I'll write it here. So we got a 2 here. I'll write it here. 2 times, we have another 2? Yeah, we do. Okay, so 2. So these 2's are gone. You can cross them out, but I'll do it mentally in my head. We have another 2 here, so we have another pair here and here, 2 and 2. And then that's all the 2. So let's do the 3's. Here's a 3 here. So 3 times, is another 3? Yep. And then we got another pair of 3's here. So I can do that as well. Okay. So these are basically all these numbers here just put down here. And now we're going to take one of the pairs out, like how we did over here. We took one of the pairs out. So from here, we got a 2, we got another 2, we got a 3, and we got a 3. Okay, so I took one of the pairs out, and now we're just going to simply multiply them out. So 2 times 2 times 3 times 3 is 36. Okay, so the square root of 1,296 is 36, and if this is like a test question, I showed my work, how I did it without a calculator. There you go. Okay. All right, so let's do the same sort of idea we're going to do with, but with perfect cubes. Okay, so just to review what a perfect cube is. A number is a perfect cube if it has 3 equal factors. Okay. So instead of 2 equal factors, which you know is square root a number times by itself gives you a perfect square. Now we're looking at a number multiplied by itself, then multiplied by itself again, so 3 times, is going to give you a perfect cube. One of these factors in the cube roots, complete and become familiar with each of the perfect cubes in the table below. So, you know, you should probably know the first 10 or so kind of generally. So 3 times 3, or sorry, yeah, 3 times 3 times 3, so 3 cubed, right? 3 cubed is equal to 27. 4 times 4 times 4 is 64, so 4 cubed is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. And to be honest, from here, I don't really don't have them memorized, but so 343. 512 is 8 times 8 times 8. 729. And this one is 1,000. Okay. So now let's do some prime factorization, just what we did up here, but it's one less step. I mean, no, actually it's the same amount of steps, but instead of putting them into pairs like we did here and then taking one out, we're going to put them into sets of 3 and take one out. Okay, so let's try this. So again, to start off with, prime factorization is exactly the same thing. So what two numbers, any two numbers that multiply into 216, so we could just do 2 times 108. Okay, and then 2 is already a prime number, so 108 we need to break down further. So we could do 4 times 27 gives you 108. And then 4 we can break down to 2 times 2. And then 27 we can break down to 3 times 9, right? And this kind of looks like 39, but 3 and 9. And then the 9 finally we could break down to 3 and 3. Okay, so now we broke down 216 to its prime roots. We got 2, 2, 2, 3, 3. And finally, we're just gonna, now instead of pairing them up, we're gonna put them in sets of 3 because we're finding the cube root instead of the square root. So 1, 2, 3, so we've got 3, 2, so 2 times 2 times 2, right? And then we got 3 3's here. So we can put those into a set of triplets. So 3 times 3 times 3. And then what you do here, you take 1 out. So just like we took one out of the pairs, since we're doing cube roots, we're taking 1 out of the triplet. So we got a 2 times a 3. Okay. And then 2 times 3 is 6. Okay. So if you didn't have this memorized up here, that's how we know that 216, the cube root is 6 without using a calculator. Okay, let's do another one. So I got a big number here. So what's the cube root of 3,375? Prime factorization is the first step. I'm going to break this down. We got our 5 times 675. And then 5 is a prime number, so we can't break that down. So 25 times 27. Okay, my camera just stopped working, but you can kind of see I broke down 27 to 3 times 9, and then 9 broke it down to 3 and 3. So we're finding our triplet sets of 3. So 5, 5, 5, so a set of 3 there. So and the next set is 3, 3, 3, right? So 3 times 3 times 3. Then what do we do at this point when we got our triplets and when we're doing prime factorizations for cube roots? We take one of them out of the set. So here's a 5, we take the 3 down, and then we finally go 5 times 3. What is that? 15. That's our cube root. Okay, sweet. Okay, next page. Let's do that. Okay, 729. So example 729. Determine if the number is a perfect square, perfect cube, both, or neither. So again, pretend you don't have a calculator for this question. So you can't do the square root, cube root button. Otherwise, you'll know right away. But if you don't have a calculator, what are we going to do? We're going to do prime factorization. And you only need to break it down really one time here. And then you can look at the sets of 3 or sets of 2 to find cube if it's a perfect square or perfect cube. Let's break it down here. So two numbers that multiply to 729, 9 and 81. And then let's break the 9 down. So you got 3 times 3. And then the 81 will break down to 9 times 9. We could break these 9s further down to 3 and 3 and 3 and 3. Okay, so there we go. So we got the prime roots. We got 3, 3, 3, 3, 3, 3. And let's put them in sets of 2 to see if we have a perfect square. And 3, we got a pair here. We got a pair here, 3 times 3. And we got a pair here, 3 times 3. Okay, so yeah, so we can fit, basically if you can fit them in pairs, all the prime numbers into pairs, then it's going to be a perfect square. If you can't fit them in pairs, then it's not going to work. Here, look, we got a set here, a set here, a set here. It works out. Can we fit all the prime roots into sets of 3 and have like nothing left over? Yeah, we can. So we have a set of 3 3's here and a set of 3 3's here as well. So that works out as well. So this is going to be a perfect square and perfect cube. Again, that's because I can find I can put all the prime roots into pairs, which is all threes in this case, and I can put them into sets of threes as well. I have like nothing left over, so it's a perfect cube as well. In part B, determine if the number has a whole square root, whole cube root, both, or neither. So this is kind of just like the next part. So remember we said it's a perfect square. So we have our threes, another set, another set. So again, to find out what the perfect square or the square root is, you take one of them out. So 3 times 3 times 3 will give you, I'll put the times sign so you can see, 27. So 27 is the square root. Okay, so the same idea we have, but now we're going to do it in triplets to find the cube root, right? So we have one set of 3, and then we have also another set of triple threes. And so you take one of them out because we're doing the cube root this time. You take one of them out, multiply it, and 9. Okay, so 9 is a cube root. There we go. So we said it's a perfect square, it's a perfect cube, and we found the cube root and square root without a calculator. Okay. Here's some practice questions. They're pretty much the same as what we just did. Okay, I was gonna skip these questions, but then I was like, okay, might as well just do one. Because this one looks a little bit differently because then it doesn't end up being all twos or all threes. So let's break this down. So it's an even number, so I'm just gonna break it down to 2 times 5,082, so 290. So another even number, so we can break that down to 2 times 1,500 or 58, not 500. And this is another even number, so we can break that down. 729. 729 is not an even number, but we can do 9 times 81. And then 9 breaks down to 3 and 3. 81 will break down into 9 times 9. And 3 and 3. Okay, and that's it. So we can't break 3s and 2s into any further. So what we're going to do is we want to find the cube root. So we're going to put these in sets of 3s. So 1, 2, 3. There's a set right there of 2s. 2 times 2 times 2. Here's another set of 3. 1, 2, 3. So 3 times 3 times 3. And finally a third set, 1, 2, 3. So 3 times 3 times 3. Remember when we have our sets, we can take one out from each. So here's a 2, here's a 3, here's another 3 from that set, and then you multiply them all together to get the perfect cube, which is 2 times 3 times 3, 9, 18. Okay, so 18 centimeters is the side length. And that's it. Okay. Looking ahead, what are we doing here? It's 3 times 3. Okay. Okay, so that'll be it for today. I think that's enough. So look at the homework for today, and yeah, so hopefully you finish the test and do the homework on your class notebook. Make sure you hand that in as usual, and that's it. All right, talk to you guys next time.